And finishing out the session, we have Michael Veale, who's going to be talking about another part of this process, so very exciting.
Cool. Thanks, everyone. I'm Michael Veale. I'm from UCL. This is work with my colleagues at Oxford, who are over there. I'm really happy to be part of such a fantastic and coherent session. It's really been brilliant, and thanks to all the previous speakers who also have done a lot of work for me. Because these issues are now there's much more awareness within our kinds of communities about these issues than there was even 3, 4, maybe even 2 years ago. My interest is the public sector. There are many machine-learned models being used in different parts of the public sector, and they're being used for a variety of things. Sometimes they're being used to automate decisions that are quite straightforward. They're trying to scale up and reduce staffing. This is things like predictive form filling, identity verification. These are questions with quite easy right-wrong answers. Everyone would kind of agree on what a right form looked like and what a wrong form looked like. I'm not going to go too much into that, but that's one area. The other one is augmentation. So augmentation is where you want to use a machine system to help you do a task more effectively. So you want to discover things you couldn't have discovered otherwise or couldn't have discovered with that same kind of level of effort, magnitude of effort. So here people are looking at things like risk scoring for child welfare, understanding abusive households, detecting tax fraud, which would be difficult to detect otherwise, organized crime, and so on. You can also split this in a different way. You can look at anticipation versus detection. So anticipation is really about future events. So where will a crime hotspot be in a couple of days' time? Which firms are likely to go insolvent? Whereas detection is detecting something which in theory could be observed today, but doing it with data which we haven't got. So thinking about, in that case, tax fraud is a good example because tax declaration is either fraudulent or not. You could, in theory, find this out with investigation today, but you want to do it with secondary sources of data. Now, the backdrop to all of this is the general literature on algorithms, which has indicated that there are many more problems with these types of systems than we previously thought. And there's a lot of research, not just the last 3 papers, working in this space. And it's a fascinating space. And it's given a few, it's got a few war stories, a lot of journalistic exposés and academic papers that have responded to them have come up with really canonical formations of this issue. So when a system is considered to be biased to or for against certain groups in a discriminatory way and may have discriminatory effects or represent people in ways that are undesirable, a common trope story is that an individual is profiled by a machine learning system. And that model will allocate a decision, for example, loan, risk score, or advertising, as been said earlier on. And upon analysis, this system is unfair according to some fairness metric. Maybe it is a violation of equality law. There are many different fairness metrics, and you can check the FATML, for example, that Alison mentioned earlier on for some of this literature. And to mitigate this, there are different propositions that have been proposed, and you can see these in areas like NIPS and ICML, where there are now streams on doing this in even the mainstream machine learning conferences, which have not been particularly socially engaged in the past, so it's an interesting trend in and of itself. So you would pre-process data or change the learning logic or the model. Similarly, for algorithmic transparency, which people think is either a virtue or something of importance to achieve maybe accountability or democratic process, a decision is made by a model, an individual wants to understand why that was made, and an explanation facility is applied to the model and that information provided to the user. So Motahari's work earlier on was an example of this kind of canonical problem. There's nothing per se wrong with these canonical problems, but they look at the machine learning pipeline maybe as a computer scientist would do, and see it as a process, the computational process that you go through. However, in an organization like a public sector institution, as we know from public policy and public administration literatures, things are a lot more messy. At different stages of this pipeline, which happen over time, people ask, hey, this data is irregular, it's super unclean, our modeler was just poached by another department, oh, we found this, maybe we want to start collecting this data now, oh, we can't use the word neural network, the minister will find that too arcane, and maybe it will be problematic for their political career. So we have to see these things in a much wider social context, not just in relation to the users, but in relation to the institutions which are building and maintaining these systems. So for this research, our core motivations were twofold. One of them is how do individuals in public agencies currently understand and cope with questions of fairness, accountability in deployed machine learning systems? So systems that exist right now, maybe they're procured, maybe they're built in-house, have people who are often civil servants because they do have some idea of public value, public service. They're not actively trying to discriminate or make intransparent systems. And so working with these users to understand how they're grappling these issues in practice today is important, and really there was no data on it in relation to statistical systems that was around the kind of risk scoring issues we were talking about today. Our on-the-ground experiences as well in these canonical sectors of algorithmic concern, risk scoring, a judicial system and so on, things that pop up a lot in the news, they at tension the real experiences that we see with these high-level descriptions of the problems that computer scientists are coming up with in FATML and other areas. So is there an alignment there, or is there actually something that is problematic that we need to work on further? This is now broken because... to do this, and I've broken massive research ethics here by taking photos of my participants, we interviewed 27 individuals who are modeling or deploying public sector machine learning systems across 5 OECD countries. The US was not one of these countries. We did that in late 2016. There's a variety of the sectors here: taxation, police, fire, council services, prison management, and so on. And we did this in a very open-ended way in accordance with a lot of the interview processes that are taken in high-stakes areas in public administration and so on. And we found several themes, and there's a lot of data here, so please have a look at the paper, but I'm going to give some quotes and summaries of these themes that we identified. So one of them are the political challenges that transparency brings. So Modelers is a taxation modeler, and she oversaw a team of machine learning modelers in-house. They noted that they can't use an intransparent system because other parts of the tax service would get wary that they were picking up protected characteristics if it was a black box. They just couldn't sell it to the other parts of the department. So there's a political reason to be transparent. But other points with transparency are a bit different. So, for example, this is an NGO analyst, and she was a part of a consortia that were developing risk scoring systems for understanding people who are at risk of child abuse, families at risk of child abuse. And in this consortia, there was a police department and a council. And they noted that one of the challenges with deploying any kind of algorithmic system is not so much what it will do in the future, but what that analysis will unearth about what you've been doing in the past. So some of this was really tangled up institutionally with a lot of institutional memory. Shucks, she said, what will this algorithm unearth? And that was what the local council were very afraid of. There are other issues that are here, and these issues are, I think, really provocations for the design community, the HCI community, and areas that maybe we have important research, important things to say about, but are not really brought to bear on this issue yet. So data really changes. Data changes over time, and there are feedback loops involved, and this is something that many participants illustrated. So someone who was leading a geospatial predictive policing project in a global city said that they deployed this system that was trained on historical data, but deployment caused displacement, dispersion, and diffusion of crime. And that threw the algorithm into a loop. So in the first 4 weeks when you trialed it on the ground, the system's performance just completely tanked. And understanding this as a process with the kind of tools they had was very difficult. They tried to put more variables in, tried to even put information about the treatments that they'd taken back into the modeling, and were building more and more feedback loops without really the ability to understand what they were doing in this situation. Because the world is complex. We assume in areas like low-stakes issues, maybe advertising, where a single advert might not change your life hugely, that the model is kind of exogenous, the data that the population is exogenous. But in high-stakes machine learning systems, the output of the model yesterday, that is the population tomorrow is a function of the output of the model yesterday. It's not always as simple as that. But that's something that we really have to think about, how we help people navigate in their domain contexts. There are also actions by other departments, especially when you use secondary uses of data. We've all heard that big data is here, and we can mine value from stuff that we previously thought was useless and administrative. However, when you do this, you run into problems. So a modeler at a police department was trying to make a system that would predict and detect human trafficking. And modern slavery is a really large problem. It's a big thing on the political agenda in many countries. That often happens in certain places. So the investigative team, different part of the police department completely, went off and investigated car washes, because car washes are a common as venue for this in the UK at least. And they did that, and of course what happened the next day? Well, the model became a car wash detector. It just flagged all the car washes because the data suddenly became very, very skewed and it wasn't distributed at random. But there was no communication mechanism between these different teams. This was about to happen. Here's how we're going to change your population potentially. Can you please prepare for this? And when you've got complex operational routines and incentives across a whole organization, these are the kind of modeling challenges that happen. And it's very easy to see how these interact with fairness and bias on the ground, because it's all about different incentives and targeting different groups. And it's not just external interactions with the world that are important. So this analyst at a national tax agency was delivering a model to auditors, but they were very afraid of providing transparency, not because they didn't like it per se as an intrinsic value, but they were worried that auditors would start judging based on the explanations they got of the system rather than on the risk score. And the explanations were simplified and may actually bring biases of their own. If it was saying that it was targeted in certain geographical locations, it may ignore the nuance. So certain areas of the country it was highlighted had higher tax fraud risk than others, but the tax agency had a duty to target tax fraud detections roughly evenly across the country. And so you might want to, and so that was a really large problem. It's actually, sorry, I've actually described something on a different slide, which is the same person talking. That's an issue. But another issue with these same auditors were that when they find an issue on the ground, they find a tax fraud issue, they might wait for that to accumulate if their wages are being paid on the basis of finding certain tax violations or not, and that's problematic in practice. Another area a theme that came up was the augmentation of outputs by users. We think a lot about algorithmic decision making, computer says no, issues around just slavishly obeying a machine and automation bias without the integration of domain knowledge. Yet in practice you see quite rich organizational routines around machine learning systems have developed. For example, in this particular police department that had built their own geospatial predictive model in-house, they previously had to give analysts about a week to build a risk model of the city. And now they could spit out a model in just a day or two from this system with a bit of work, and then the analysts spend the rest of the week reading all the news reports and augmenting this map, saying things like, we know we've caught this particular burglar now, this area is going to be less high risk next week, or we know we've changed all the locks in this apartment building, so the burglary risk is going to be considerably lower. And how we actually enable that is, I think, a real challenge. But also, when you augment outputs, it's about individuals using that model on the ground. So giving that model to people and just saying, can you please do what this says, has been demonstrated, at least by many of the respondents that were the participants in our study, to cause resentment. People don't want to obey this system, they want the discretion. And if you give them different options, they can choose between them and integrate their own knowledge. Now, this discretion is a theme that came up more broadly in different areas, and it's another theme that we pull out. So, firstly, discretion and the role of discretion and over-reliance and under-reliance is application dependent. So in this police department across our whole country, they had different predictive systems they were giving to users, but they found that helicopter pilots really hated them because they were used to being given freedom to go where they wanted to go. This was about anticipating where crimes might happen and need helicopter support, so put them in the right part of the country, overnight, for example. However, motorcyclists loved this. They just wanted to go bam, 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 go here, go here, go here. And that was really very positive for their work ethic. And they found, yes, this is why we joined, this is what we like to be doing. So we can't make huge assumptions about how this works across domains and sectors. Secondly, discretion is also output dependent, so it depends on the directionality of the model response or the classification. So while this is a system that was used to allocate resources like training courses within the prison system to people who they might benefit the most, and this is an example of a system that's working on recidivism and risk scoring but isn't being used to actually assign sentences and so on, which is much more common in other parts of the world. And these rules can be based on output thresholds. We could say you get this score, bam, here we go, you've got this result. But it would also be linked to professional judgment. However, the concern there was only when people agreed with this decision would they use a system, and when they disagreed they wouldn't. And that would introduce problematic areas into this as well. Lastly, in this area, this is what I mentioned earlier on in relation to the tax fraud, judging on the explanation, not on the actual results. So that was my fault for putting that in the wrong section. Sorry. Another section here is around moving practices. These, when you establish a machine learning system or a routine in an organization, how does this come to be? And what are the challenges there? One of them is we think that fairness is a primary issue and we want to analyze the data. However, increasingly, for example, in European data protection law, you have to do privacy or data protection impact assessments before you undertake any analysis at all. So understanding issues around fairness, you often need to do this before you have access to the data set you want to use. So you need to draw in external sources of knowledge to understand what correlations you might have were you to link this data together. So that's a real practice, a problem that occurred with many respondents, and they didn't have access to these kind of fairness tools because they weren't able to do in-data analysis until they showed what they were meant to be expecting and the kind of fairness problems that could emerge. Lastly in this section, there was a really big problem with when you set up an institutional routine that was pretty hard won, how you box it up and send it elsewhere. So this police department had made a predictive policing system, and it was the same police department that augmented the knowledge, had meetings, understood what had changed in the week around this. However, they were worried that just boxing up the software and giving it to the police department next door would mean that that police department did not take on that learning and did not bring the institutional routines with it. And that was a real worry they had when they were spreading out. I'm just going to go to the conclusions and I think where HCI energies are needed in the future in this area. So firstly, we need to learn better and support better linking actors across complex institutional data pipelines to avoid different kinds of model failures, especially when there's changes in data and collection or processing practices change. And this is actually a challenge because you've got people with very different roles, very different motivations, ways of working, and kind of interfaces they use. And I think that is important to make sane systems as well as ones that are fair and accountable. Secondly, we have to allow individuals to negotiate and augment complex model outputs with their own domain knowledge. So thinking what happens after the model output happens and how people can meaningfully engage with this. Thirdly, we would need to help low-capacity organizations, and many of these are designed for augmenting people in particularly low-capacity areas with little operational intelligence, to adopt these technologies without losing the lessons that were really hard-won in the making of them. We also need to understand more about how people over or under-rely in different contexts on technologies and not make sweeping generalizations, help individuals understand fairness issues in data sets they haven't encountered yet, and to navigate and communicate, this is one of the last quotes I didn't give, it's in the paper, performance and uncertainty metrics where there are really imbalanced data sets. Because in these cases, it's really hard to say what works and what doesn't when you're dealing with predicting rare events, because if you just said no to everything, you'd have 100% accuracy. And that's hard to navigate in political organizations. So thanks for that. There's probably a tiny bit of time for questions, and check out our paper. Thank you very much.
I encourage you guys to come up and ask questions now, but I'll start with one of my own, which is, for these practitioners, do you get a sense of where they're turning for information outside of their organization for guidance about how to think about these sorts of problems they're encountering?
So there are some institutions that are setting up networks between organizations. Mostly they're really informal Skype calls, actually, between different people doing this work, and that's interesting in and of itself. There's a lot of interest inside government in FATML, and people are actually reading these papers. There's nothing deployed that they can use, so that's a kind of a shame for them. But there's really a lot of interest in institution building, especially in the UK. We've seen that a lot.
Hi, Alex Taylor, City, University of London. You do a beautiful job of capturing the complexities of organizational life, decision-making, and bias. And I guess the challenge I've had in encountering the machine learning and AI field is that you were dealing with a community that believes that bias is an instrumental problem that can be solved.
Yeah.
And so, as Alison showed so nicely, that these problems have long histories. They're deeply ingrained in social life and the structures that we live through. And how do you communicate with a community problems that aren't going to get solved? So these sorts of issues that you report are not things that are going to get fixed.
It's a tough one. It's a really tough methodological problem. I think it's a hard it's a hard pill to take for a lot of communities that are used to having optimization as a result. It's one that communities have taken, whole research communities have taken before. Alice and I were talking recently about the environmental community, which did go through a period of willingness to pay, carbon trading is the solution, and now is really aware this is a wicked, tricky problem that you can only manage and not solve. I think it's going to be tough, but we have to keep engaging, and we've seen give in similar areas before. But thanks.
Around Television University, first of all, thanks for putting algorithms in context. It's really, really interesting. I wanted to ask about the kind of reverse effect from the algorithm to the organization. So we talked about a lot about how the values of the organization are reflected in the algorithm, but some of those algorithms come from packages or products you can buy. And did you see any evidence of the way they change the organizations?
Yeah, so there's increasing wariness in organisations around procurement as being a challenge here. In the UK, we're releasing guidance soon. We've been working with the government to release guidance to help people at the very beginning stage of procurement think about these issues that might happen at the end, what they need to negotiate during contract as a result of that. Procurement's typically been a really important policy lever. Put a standard in for procurement. That's what created green building standards. Public sector organisations saying we're not going to stand for this. All public buildings have to meet this standard. That's a challenge, but working with the people in the procurement side who are not used to operationally seeing their technologies be deployed, they're a very different skill set, is another big challenge, because we're communicating how they need to negotiate what they need, especially when we're not really sure what as I said, these are big challenges, I think, for HCI. We're not sure what to tell them on a plate. That's something that we should go for in the future, and I'd love to see people in the room engage with really non-traditional actors like people doing contracting on these challenges.
Thank you.
Let's thank Michael and the rest of the speakers.